Hello guys and welcome back. So now we're gonna continue and improve this emitter, and what I want to do is I'm going to fade this effect along the path of the curves. Instead of having this uniform volume here, I want to fade it. I want it to be dense here and then it fades off. Okay, let's take a look at how we can create that. If we find a way to make a ramp along the length of each curve, we may be able to use that information to modulate the density here. So let's see how we can get the length of these curves. Well, we can loop over each of these curves and then take the point number. Let me simplify it. We can take an edge, a primitive. Let me blast this guy. Delete non-selected. We can take this guy and then divide the maximum number of points by the total count. We can divide the point number by the total count plus 1, so we get a linear value that goes from 0 to 1. But this requires each curve to be isolated, so we have to put down a for each and then loop over each primitive, and it's going to be slow. So what we can do instead, we can create a UV coordinate on the geometry, and this is going to be a parametric UV coordinate, and it's going to figure out, it's going to create a UV coordinate that goes from 0 to 1 on the U for the curve length. So it's going to give us a U value that goes from 0 to 1 along each curve. And the way to do that is using a texture node, and we're going to set the texture node to rows and columns. And now we have a UV vertex attribute. I don't want it to be a vertex attribute, I want it to be point. And I'm going to put down an attribute wrangle and show you guys this value. So I want to use color v at cd dot equal let's say dot x equal uv dot x. Okay, and now we have, let's use the full CD, and now we have this ramp that goes from 0 to 1 for each curve, and it is normalized, and this is great because we can use this information to modulate the density of this guy. Cool. So how are we going to do that? Well, first we have to tweak this data. So let's put down a point VOP and make it look correct, because right now it's not. It's black here and white here, and we want the inverse. So let's put down a point VOP and import the UV coordinate. So bind UV and then change it to float, 3 floats, and then we're gonna split that vector into 3, and we're gonna take the X, which is the U coordinate, and put that into a ramp. As simple as that, and plug it into the color, and let's look at this result. Currently it's the same, but we can flip these guys and we can decide how this is going to fade along the curve. Cool. So let me lower the resolution of the voxels so it's faster to work with, and let's see how we're going to do that. Well, currently when we do the conversion, and if we middle click, we see we have density here. So, and density is simply creating a voxel for each point with a density value of 1. But there is this point attribute here that we can use, and what this allows you is to do is you can create extra fields on VDB, and you can sample points. You can sample values from the points and pass those into the VDB. And in this case, we're gonna select the attribute to be, let's see, what is the attribute? Let's bind this into something more reasonable. Let's bind export this into something that we call length instead, and it is float, and I'm gonna change this to I want the R channel vector to float, and that's it. So now we have a length attribute that represents that. And if I go through this list, there is this length attribute, and now it's gonna stamp. You can see the display is different because there is these two fields, and I can specify a different name for the length. I'm gonna just name it length. I can leave it the same. I can give it a custom name. This is just the name that it's going to use. You can see it's a type float, and that's what the attribute is. So now we have a second field that we can use, and it messed up the display, so I want to fix that. And how do we hide those things? Well, we can use a node called visibility, and we can type in name equal length. That's the name of the primitive, and if it is equal to that, we want to hide it. Okay, so it is hiding that information. And then we're going to use a volume VOP, and in this volume VOP we're going to dive inside, and we're going to bind import the length. We can do this with fields. We can import any field we want, because we don't need the samples as long as we're gonna access the same data. We're gonna just read the data in. We don't want to change the way we read it in. We can simply use the bind nodes. And I want to use a multiply node and multiply that length by the density and see how this looks. Sweet. So now we have a smooth transition using the curve, using that ramp that we just created. And if I play with the ramp, you will see how it's gonna affect. You see it's shorter now, and basically this way we have filled the gaps of the sim. And if I play this through, there will be no gaps between any frames. Especially we're capturing through 4 frames. We can go higher, it's not a problem. We can go higher and fade it more, but this should be enough for now. And then we're simply going to write this, put down a ROP output, and then write this to disk. Now the important part, as we mentioned before, is to have the same resolution as the DOP sim. And in this case, this is a heavy process. So what we can do is we can write this at a high resolution or mid resolution, and then work on the sim, and then go back and write another one. That's one option. Or we can write this at a high resolution, and then change, and then import that high res and change it, resample it to match the new settings, so we don't have this mismatch. And we can do that using a VDB resample. So let's say this is our high res version, and our sim is at 0.5. We can use this VDB resample here and change it to, let's see, not this one, using voxel size only. And for this guy, we can change it to 0.5, and that will resample the data to match it, what we have. We can also go lower if we want. If we want to do that, we can, but it's not going to add more definition to the sim. So I'm going to write this out to disk, and I've used a different value for the scatter and for the let's see, for the min and max, but it's the technique is pretty much the same. I'll show you the emitter, and you guys can be the judge of that. And then we're going to set up the smoke sim using this emitter. Thanks for watching, and see you in the next video. Bye bye.